There is a company so powerful that if it disappeared tomorrow, the giants we know, Apple, Nvidia, TSMC, Samsung, would all grind to a halt. The entire global economy and the technology that defines our lives rests on a single point of failure, a company most people have never heard of. That company is ASML. And today, we are going to pull back the curtain on the invisible giant at the center of the world. How can a company worth hundreds of billions of dollars and responsible for the modern world remain so obscure? To understand ASML, we have to go back to 1984. It began as a joint venture between Philips and Advanced Semiconductor Materials International. They are the world's only manufacturer of extreme ultraviolet, or EUV, lithography machines. Without these, the chips in your pocket simply couldn't be built. They started in a leaky shed next to a Philips office. At the time, they were a tiny underdog in a market dominated by Japanese giants like Nikon and Canon. Which leads us to Section 3, the machine worth hundreds of millions. Each of these machines costs over $150 million. But what's inside them? The industry was skeptical. Why would a small Dutch startup be able to compete with the engineering might of Japan? In 2001, ASML released the Twin Scan. It allowed them to process one wafer while the next was already being aligned. It doubled productivity overnight and cemented their lead. Imagine a machine that can hit a target the size of a golf ball on the moon with a laser. Now imagine doing that 50,000 times a second. That is the precision of EUV. The wafer table moves with an acceleration greater than a fighter jet, yet it must stop within a few atoms of its target. Every single time. But ASML had a secret weapon. They were willing to collaborate with anyone, anywhere, to solve the most difficult problems in physics. The wavelength ASML uses is 13.5 nanometers. This isn't just invisible light. It's so close to X-rays that it doesn't behave like light at all. But why can't a trillion-dollar powerhouse like Apple or a nation like China simply reverse engineer this? Traditional lenses are useless here. EUV light is absorbed by glass, air, and even the mirrors themselves if they aren't perfect. The journey to EUV took over 30 years of high-stakes R&D and billions in investment before a single chip was ever made. To reflect this light, Zeiss had to invent a new kind of mirror made of hundreds of alternating layers of molybdenum and silicon. ASML bet the entire company on a technology that many experts thought was physically impossible. They spent $9 billion on the gamble. The tin droplet generator is basically a high-tech inkjet, but instead of ink, it fires molten tin at 250 miles per hour. Take the mirrors. Crafted by Zeiss in Germany, they are the flattest surfaces ever produced by humanity. It requires a double hit. A small laser pulse flattens the droplet, and a second, massive pulse vaporizes it into plasma. The EUV light is created by a plasma that is 40 times hotter than the surface of the sun. Keeping that heat from destroying the machine is a miracle of engineering. So why can't China just buy one machine and copy it? Because an ASML machine isn't just a product, it's a living system. If these mirrors were scaled up to the size of Germany, the largest imperfection would be less than a millimeter high. There are over 20 million lines of code running inside. It's perhaps the most complex software-hardware integration ever achieved. Because EUV light is absorbed by almost everything, including air, the entire process must happen in a perfect vacuum. With over 100,000 individual parts, the assembly manual alone would fill a small library. Many of these parts have their own unique supply chains. Then there's the light source. It requires hitting a falling droplet of molten tin with a CO2 laser. ASML engineers actually live at the customer's factory. They are the only people on Earth who know how to keep these machines tuned. This leads us to the three musketeers of ASML. First, Zeiss. They provide the mirrors, the most precise optics ever made. Intel famously bet against EUV early on, thinking they could achieve the same results with older technology. It was a multi-billion-dollar mistake. This happens 50,000 times every single second. Every single pulse must be exactly the same. Meanwhile, TSMC bet everything on ASML. That choice is why they now manufacture over 90% of the world's most advanced chips. By 2012, the cost of EUV was so high that ASML couldn't do it alone. In a move never seen before, their biggest customers, Intel, TSMC, and Samsung, all bought stakes in the company to fund the research. Second, TRUMPF. They build the most powerful industrial CO2 lasers on Earth, specifically for ASML. They weren't just buying shares, they were buying the future of their own industries. Without that combined $15 billion bet, EUV might have died in the lab. This has created what experts call the silicon shield, the idea that Taiwan's dominance in chips, powered by ASML, prevents a war. Shipping just one machine requires 3 747 cargo planes and 40 specialized shipping containers. For the US, ASML is a strategic asset. If China gains access to EUV, the military balance of power could shift overnight. And third, Cymer. An American company, ASML, eventually acquired to secure the world's most advanced light sources. This has led to intense diplomatic pressure on the Netherlands, turning a private company into a pawn in a new technological Cold War. The assembly takes months, performed in clean rooms 10,000 times cleaner than the air you are breathing right now. Recently, China managed to produce a 7-nanometer chip using older ASML machines. But without EUV, they are hitting a physical wall. The United States has successfully pressured the Dutch government to block exports of ASML's most advanced machines to China. These machines will allow us to shrink transistors to 2 nanometers. That's the width of a single DNA strand. Without these machines, China's dream of leading the AI revolution faces a massive, perhaps insurmountable, roadblock. ASML isn't standing still. They are already shipping their next-gen machines, high-end AEUV. They are even bigger and even more expensive. The United States has successfully pressured the Dutch government to block exports of ASML's most advanced machines to China. In the 20th century, nations fought over oil. In the 21st, the battle is over the photons etched by ASML. Each high-NA machine costs nearly $400 million. Only a handful of companies on Earth can afford to buy even one. A single disruption in Veldhoven wouldn't just be a business problem. It could trigger a total global recession. It's a race to reshore the most advanced manufacturing on Earth. But no matter where the factory is built, the heart of it will always come from Veldhoven. But is ASML truly untouchable? Japan's Canon is fighting back with nano-imprint lithography. Instead of complex light, it physically stamps the circuit pattern onto the wafer. The energy required to run these machines is also staggering. An EUV fab consumes as much power as a small city. This concentration of technological power is unprecedented. We have placed the entire future of humanity in the hands of one company. Canon claims it uses 90% less power and costs a fraction of an EUV machine. If it works for advanced chips, ASML's monopoly could finally face a real threat. The next-gen high-NA machines are so large that ASML had to build entirely new, taller factories just to assemble them. One module alone weighs 12 tons. TSMC is ASML's largest customer, housing dozens of these machines in their multi-billion-dollar semiconductor fabs. This isn't just one company. It's a global ecosystem of 5,000 specialized suppliers. If one fails, the whole system stalls. Canon claims it uses 90% less power and costs a fraction of an EUV machine. If it works for advanced chips, ASML's monopoly could finally face a real threat. This concentration of technological power is unprecedented. We have placed the entire future of humanity in the hands of one company. The next-gen high-NA machines are so large that ASML had to build entirely new, taller factories just to assemble them. One module alone weighs 12 tons. TSMC is ASML's largest customer, housing dozens of these machines in their multi-billion-dollar semiconductor fabs. Installing one takes over 6 months and a dedicated team of 250 engineers. It is, quite literally, the most complex logistics operation in the history of business. For the Netherlands, ASML is a double-edged sword. It's a source of immense wealth, but it puts them at the center of a global crossfire. Every high-end chip in an iPhone or a MacBook was birthed inside one of these machines before traveling the world. From a leaky shed to a global monopoly, ASML's story is a testament to the power of persistence and the fragility of the modern world. This concentration of power creates a single point of failure for the entire modern world as we know it. But what happens when we reach the physical limits of silicon? When ASML can no longer shrink the world? That is a story for another time. Underpinning everything ASML does is Moore's Law, the prediction that the number of transistors on a chip would double every 2 years. A fire, an earthquake, or a sophisticated cyber attack on ASML's campus would be a catastrophe for the global economy. ASML relies on a highly specialized workforce. If that talent leaves, or the knowledge disappears, the digital age stalls. Right now, the race is on for 2 nanometers. Only ASML's next generation, high NAEUV, can get us there. When walls are only a few atoms thick, electrons start to leak through them due to quantum tunneling. This is the wall that ASML is fighting against. There's also the economic wall. It's not just that it's physically harder to shrink, it's exponentially more expensive. ASML is the only one who can still afford the race. There's also the economic wall. It's not just that it's physically harder to shrink, it's exponentially more expensive. ASML is the only one who can still afford the race. We often talk about the brands we use every day, but we ignore the company that makes them possible. Section 8. The Silent Architect. In a very real sense, ASML is the sole steward of human technological progress. If they fail, Moore's Law finally dies. ASML is the invisible giant, the silent architect of the digital age, holding the keys to our technological future. ASML is the invisible giant, the silent architect of the digital age, holding the keys to our technological future. If you found this deep dive valuable, hit subscribe for more stories behind the technology that rules our world. I'm Ethan Cole. Thanks for watching.